morning, guys. Well, this is day 7, part 2. So the first thing I want to do is I want to show you in my physics book what I have done. So what I have done is I am still working in this book. And like I said, you can start your brand new book on Monday if you want to. But I'm going to continue with this book until I get mine filled. So what I did is I went back and I went through week 1. Okay. And so week 1, I just put down the pages that were supposed to be study guide, and the test supposed to be right here. I don't have them in my book, so I didn't put them there. And then this is week 2. So our weeks are going to be a little bit different this time. It's actually going to have not Monday through Friday, but it's going to run through the assignments e-learning online. Now, if you want to put it on the top and put e-learning on here, that's okay too. Okay? L-E-A-R-N. Sorry. I-N-G. So, what we're going to do is we're going to go ahead and start with today. We did, and so if you want to look what mine looks like from where we started. So here's where we've kind of started at. I'm just putting like chapter 7, section 1, what the page is. I'm putting some headings on here. I'm kind of pretty much showing everything that I'm doing with the problems. And here is everything that I have up to this date. And so today, what we're going to do is we're going to start on day 7, chapter 8, section 2, and then dynamics is what you did yesterday. And so this was going to be where we're going today, which is right here, 211 to 213, which was the second part of it. So in the textbook, I am on page 211. And on 211, it shows a picture of a drawing. And on that drawing, it actually shows you a picture of a truck with a wrench on it. And what it does is it gave you an example. And what I did is I just kind of drew the example. That's better. I kind of drew the example for you to see. And then I was like talking about how the wrench has a longer lever arm, which you have to have less force required. That's the reason why they're using such a big wrench on here, because they want to use less force because it's such a big tire. So then also what it did is it gave you an example of 2 colored pencils, and then if you tape the coins on the end, and it was talking about if you were looking at the formula, this is what it would look like. But this right here is what I want to look at. I want to look at what's going on with the diagram. So with the pencil going across the other pencil, okay, pencil going across the other pencil, you have a force gravity 1, force gravity 2, radius 1, and radius 2. This is very important before we start doing the problems. So now I'm going to go to the example problem on page 212. And it says Kyra is 56 grams and Alyssa is 43 kilograms. Wants to balance on a 1.7 meter long seesaw. Where should be placed on the pivot point on the seesaw, assuming the seesaw is massless. So what I did is I just drew them, okay? So this right over here is your force of gravity on K, which is Kyra, and then your force gravity on A, which is your Alyssa. This is your radius for Alyssa. This is your radius for Kenya. So what do we know? We know the mass of Kenya is 56 grams. We know that the mass of Alyssa is 43 kilograms. We also know that R, K, and RF. That means the length between them. It tells us in the reading assignment that the seesaw is 1.7 meters long. So that right there is the seesaw, okay? And then it's asking for the radius of K and the radius of A. So before we do that, we have to actually figure out what the two forces are. So we're going to start with Kira first. So she has 56 times 9.8. Remember, 9.8 is gravity, and then you'll get this number. Alyssa, then you're going to have 4.3 kilograms. That's how much you weigh, times 9.8, and that will give you them. The next thing you have to do is define the distance in terms of the length of the seesaw. Well, we know that the length of the seesaw is 1.75 meters. And what we're trying to do is we're trying to find out how far these girls need, where we need to have the fulcrum at to be able to make them do the seesaw. So to be able to do that, it shows you different types of steps on how to find the torque to be 0, because that's what we want. We want to find the torque to be 0. And then after that, we can actually, once we do that, then we can figure out what is the radius of A. So we're actually looking for this right here, RA. Okay? So what we're going to do here is we're going to take the formula that we have here, and here's our math. So what we're going to do is force of Kenya, and we're going to times 1.75 meters. And then the force of gravity on Kenya and the force on gravity on A. Okay, so in our calculator. So let's turn it on. Cool. So we're going to do, that is a fraction again, right guys? So alpha y, enter. We're going to do open bracket 5.5 times 10 caret 2, close bracket, open bracket, 1.75, close bracket, open bracket, 5.5 times 10 caret to the 2, close bracket, nope, we're not going to close bracket, we're going to add 4.2 times 10 caret to the 2, over, and then down. And then we're going to hit enter. So it tells me that I have done something wrong. So let's go back up. Let's go back into our equation. So what I need to do is up here. Do you see what I did? I did something wrong. So I'm going to go and take all this off. Now listen, I have found out by using this calculator more than I normally have ever used it. If you use the delete button, it works. If you want to insert something, second and then insert, and you can actually put something in. So I need to have caret 2 over, close bracket, open bracket, 1.75, close bracket. Let's see, 5.5 times 10 to the second plus 4.2 times 10 to the second. Everything looks good. I'm going to go over to the end to say I'm done, and I got 0.99. So there is the sample problem, and now what we have to do is I'm going to have to be able to do the next problems. Sorry. Okay, so then what we're going to do now is we're going to look at number 16. A shook whose mass is 43 kilograms and sits at 1.8 pivot at the center of a seesaw. Steve, who is the mass of 52 grams, and then he wants to seesaw with a shook. How far from the center of the seesaw does Stevie have to sit? So what we're going to do is we're going to do pretty much what we did before, and we should get 1.5 meters. Number 17, a bicycle chain has a radius of 0.770 centimeters. That's my radius. If the chains exert 35 newtons of force on the wheel, there we go, and on the wheel clockwise direction, remember clockwise is negative, counterclockwise is positive. So let me write that down on the top. So I'm going to put on mine that clockwise is negative, and I'm going to go and I'm going to highlight it so I'll remember that why it is a negative number. Then what you're going to do, go back to the question. What is the torque needed for turning the wheel to turn? So what we're going to do is we're going to take our negative 335 and multiply it by our radius. Okay, that's going to give us 0.27 newtons. And for it to be balanced, you have a negative 2.7 and a positive 2.7. Number 18, stationary basket. So what I did is I just went ahead and drew the diagram for myself so I could see it. From a string going around a pulley has different diameters shown on schedule on figure 10. Now, so what I'm going to do here is I'm going to look and I'm going to do my math. So I'm going to take my 23 grams, I'm going to multiply it by my 1.1, and I'm going to divide that by this, because I'm taking this side from that side, and I get 0.56. Number 19 says, suppose the radius of a large pulley has a problem of 18. Okay, so I have a large pulley, and it increased to 6.0. What is the mass of the basket now? Well, I'm going to take the mass 2, which is 23, my radius 1, my radius 2, which is 1.1, but now I'm going to go ahead and change it to, and it says it increased to 6 centimeters. There. So one thing I'm doing is I'm doing the same problem, except I'm changing the number. Okay? Oh gosh, you can't see none of it, can you? Sorry. So that is 19, and that is, so I'm going to move mine. That is 19, and that is 20. Okay?